Hi everyone, this is part 2 of 3.4. I stopped off with, I was talking about negations of not P and not Q, and I wanted to just touch base a little bit that if this is false, or that if P is true, to negate it is to take it to false. And if it's false, just like in this case, it's negated to true. That's what I meant by my last statement. I just want to make sure you 100% understood that. So now on to the next column. I'm looking at this column right here, and what I'm going to do is I'm going to use these previous cases of the P and Q to make P if P implies Q. So T implies T in this case, so it's true. Here we go for this one. T implies F. This is the lie, so this is a false statement because the consequence did not happen when the action of the condition of when the condition was of P was upheld. For this, we say F implies T, and this is T, because remember, in all cases, it's true, unless you have a true P and a false Q, so the false implies false is true. All right, so that's that column. And I'm just erasing it to get some of this noise off. Here we flipped it around, so be very careful when you do this. With this column right here, Q is now different, so we just need to make sure that we don't get those confused. So when Q is true, when T and a lot going on here. Go slow here. All right, I'm on this. When T is true and implies true, that's a true statement. When F is false and when Q is false and P is true, implies this is a truth. Once again, T is true, implies the P is F. This is the lie, so this is false. And here we have, once again, false and false, so this is true in all cases. So we have that truth table. I'm going to double check myself on this because make sure I'm getting these correctly. So true, yep, false, true, that's true. And then we have true, false. Yep, this looks good. If you notice, things kind of got flipped around here. Right? Very interesting. If you notice, going from this column down, it looks the same as this column going up. So, now the inverse. The inverse is saying not P implies not Q. So this is false implies false. So that's false for this case. This is false implies true, which is true in this case. And then for the next one, we have a true and implies false. And this is the case of the lie. So this is the false statement right here. And then we have T implies T. So it's true. All right, so that's what that looks like. And I think you guys are getting the hang of this. I'm going to double check this because we need to make sure. I did make a mistake right here. I apologize about that. So this is false implies false, which is true. This is false implies true, which is true. And this is the case of the false. Yep, we're good to go. Okay, sorry about that. I'm back on the train, guys. Here we go. So now that's the inverse of the if then. The P implies Q. So now let's look at the contrapositive. This one's a little bit trickier because now we're looking at not only the Q implies P, but they're both negated. So it's not Q implies not P. So we need to look at these columns, not erase them. We need to look at both of these in order to fill out this column right here. So not Q is F, not P is F. So this is true. Not Q is true implies the false P. This is the lie. This is true. Whoops. This is false implies true. So this is true. And then we have true implies true, which is true. So now if I did these correctly, we should have some equivalent truth tables. And if I made a mistake, by now you're probably like, Miss Coco, you made a mistake. But, you know, that's a part of the game when you're teaching in class. So let's see if we have some truth tables that look the same here. So these two truth tables, the original if-then, the contrapositives should have the same truth tables. And it looks like they do. It looks like Miss Coco did it right. So these two, this conditional statement, the P implies Q, and its contrapositive are equivalent truth tables. So they're equivalent. All right, they're equivalent statements. And if you notice the converse and the inverse, well, if I did it correctly, their table should also look true. And I did. If you notice right here, this is equal to this. So these are equivalent statements. So yes, awesome. So our next thing that we're going to do is we're going to determine related conditional statements. Okay, so for a statement such as not P implies Q, we want to write the following. We want to write its converse, inverse, and contrapositive. And in order to do this, you need to look back up at the original table, and you need to remember what a converse is of the original conditional statement. So it's where you just flip them. And once you know that, you can scroll back down, and you can say, hey, the converse is taking Q and moving it to the front of the sentence and taking P behind the then, and I get this statement right here. Q implies not P. So they're just flipped. So this is the case of them being flipped. So you got to flip it. The inverse is taking and negating both statements. So when you look back up here, this inverse, it took the original if P then Q statement and just negated both of them. So let's do that with not P then Q. So I'm going to erase this right here, take some of this noise off. So we'll first take the original statement, not P then Q, and then just negate each one. Put a negation in front. I'm going to do it a little bit more expanded. I'm going to negate not P implies negating the Q. Right here, this is saying not P. This is saying not P, not Q. This right here cancels out just like with two negatives being multiplied. It becomes a positive. The same thing kind of happens here. You can think of it in the same way. And you have P implies not Q. So there, we got that answer. Now, try this one on your own and see what you come up with. The answer is in the book. All right, so now this next topic we're going to do is a little bit more of a challenging topic. It's alternative common translations of if P then Q. All right, so let's look at these further. I'm going to erase some of this. Get this out of the way. All right, let's see if I can do this. All right, so alternative common translations of if P then Q. Remember, it's that conditional P implies Q, and it can be translated in any of the following ways. And guys, everyone, I should say, when you're actually taking words to if-then statements, you can also use these as well. All right, and I'll show you how to do that in a second. All right, so the first way is if P then Q. That's how you can translate a statement into a conditional statement. You can also say if P, comma Q, period. We always say P implies Q, P only if Q, P is sufficient for Q, Q is necessary for P, all P are Q, and Q if P. These are all the ways, all right? They're all equivalent ways of saying it. So let's see this in action. The next objective that you're going to do in your homework is rewording conditional statements. So what we want to do is we want to rewrite each statement in the form of if P then Q. So here we go. The best way to do this is to look to see if you have any, look back at this list up here and see if you have any words that will signify where P is and where Q is. Remember, P in this statement is the antecedent and it is the conditional as well. So it's the condition. So when you do these, the first step is to see if you have any buzzwords, like right here we have if, and to see, once you identify what P is, see if it makes sense to make sure it's a condition. So let's look at A. I'm going to pull it down here because we have a little bit more space. You'll starve if you don't eat. All right? So we have if, and up here, it says Q if P. So to me, because there's this if and no other words behind it, it doesn't say only if. It doesn't say sufficient, necessary, implies P, or any of that. To me, this big if, I forgot I rewrote it down here, says that after this if, it may be P. And that before the if may be Q, because I am looking at this statement, Q if P. Well, let's see. If you don't eat, you'll starve. Well, you don't eat, that sounds like a condition to me. So what I'm going to do is I'm going to rewrite it. Because I want to put it in that form. That's my second step here. This was my first step. Second step, I'm going to rewrite it in this form of if P then Q. Or they actually said we want to write it if P then Q. So I'm going to erase that because we don't need that. We want to rewrite like this. So I'll take what I identified as P, put it in front of the if for my third step. If you don't eat, then, because we need the if then, because that's our goal, then you'll starve. So this is our end statement. This is how we wanted to rewrite it, if then. Now, one thing I want to mention with these is that you really do need to know this list, so I would memorize it, make note cards, make your life easier, because it's going to make rewriting these rewording conditional statements like this and putting them from an original statement such as this one into an if P then Q statement. Because if you notice, I was able to identify that this was similar to the case that I was looking at, and that this was going to be P and that this was going to be Q. And whenever I said it, it did sound like it was a legitimate condition. So use this list right here and all of its glory to help you create these. So let's see one more. I'm going to erase this so we have more room. Let's look at part B. So we don't need to do that. Oops, didn't want to do that. I'm getting with the game, guys. I'm getting with the game here. All right, so part B, it's because I'm not using my pink. It says, go to the doctor if, only if, your temperature exceeds 101 degrees Fahrenheit. So right here, only if really sticks out to me. So my first step is to identify the terms that can be translated into this if P then Q statement. All right. And what I mean by that, because it's kind of hard to get my ideas across, is that I identified that only if sounds very familiar to one of these these translations up here that I gave you. And right here, especially, this says P only if Q. And I have only if. So if I let P equal go to the doctor, and my Q, this is the only if that's connecting them, and my Q equal your temperature exceeds the 101 degrees. Then I know that I'm putting P first. P can be substituted or rewritten using my if P statement, like so. So what I'm going to do is my third step is I'm just going to substitute my P in for here, and I'm going to substitute my Q in for here, and I'm going to rewrite my statement. If P, which is if, well, we have to kind of reword this too. Excuse me. If you go to the doctor, you have to put the U in there because you have to have a subject area. Then your temp exceeds ... the 101 degrees. This should be 101 too. All right, so remember I had to add this U, so that's why I hesitated. Remember, these have to make sense. When you create them, they have to be complete sentences, but just a heads up because I hesitated and I didn't want to confuse you guys. But this is your end result right here. I was able to identify that because of that only if term that was connecting the middle term, the two statements. So that's how you reword conditional statements into if-then, into the form of if-then. So just to summarize that one more time, we're taking statements like this, but they have words such as these, and we're putting them into this form right here, if-then statements. See if you can do C before you look at the answer below. Some of you might have already seen it, so pause it right now, see if you can do C, and then the answer is below. All right, so our next one. Now we want to